A support agent needs permission to create one ticket. It does not need the bearer token that authorizes every ticket operation. And if that raw token ever enters the prompt, a malicious email, document, or tool response can simply ask the model to repeat it. So the durable design is credential blind execution. The model proposes an action, a deterministic policy authorizes it, and a trusted executor injects the credential only while making the call. Start with where a secret can live. An agent touches a credential in one of three places: its prompt, the process environment, or a tool executor. Only the third is a good default. Prompts are observable by the model and may show up in traces. Environment variables are invisible only until you hand the model a shell, a debugger, a file reader, or an error log that leaks them. A narrow executor keeps the secret behind a typed operation, where the model can never read it. So the rule is blunt. Telling the model not to reveal secrets is not a control. The model must not possess the secret in the first place. Now the key move: put policy between the plan and the action. The model can propose create _ ticket with a customer and a summary. It cannot decide whether this user may create that ticket or pick a broader scope or attach a token. Those are deterministic checks. Watch the code. You define a typed action, then an authorize function. It reads the user's scopes, builds the required permission from the tool and operation, and denies if it is missing. If the action is an external write, it returns approve, pausing for a human. Otherwise, it returns allow. The placement is everything. After the model produces a structured action and before the executor dispatches it, an input-only guardrail cannot see the final tool arguments. An output scanner might catch a literal token, but it cannot tell whether delete _ repository on prod was actually authorized. When a token must exist, give it 4 properties straight from the OAuth security best practice. Scope: what operations it may perform, so a read token cannot delete or send. Audience: which resource server accepts it, so a token for drive is rejected by Slack. Lifetime: how long it is useful, so short-lived tokens shrink the replay window. And sender constraint: proof of possession like daypop or MTLS, so a thief with only the token string cannot replay it. These do not excuse a leak, they make a leaked credential less reusable and less powerful. And one sharp caution: PKC protects the code exchange, but it does nothing once an attacker holds the bearer token. Audience, lifetime, and proof of possession are what reduce replay. So the production checklist is clear: keep secrets out of prompts, schemas, env dumps, and logs. Let a server-side executor fetch up a user per tool credential only after policy allows the typed action, reauthorize at the resource itself, and gate the irreversible actions behind explicit approval. The model chooses the action, it never becomes the credential store or the authorization server.